Hello, everyone. Welcome to our last event of the day, the Blue Team Village Lightning Talks. We have some really awesome people here to give some really short talks on some really fun subjects. So to kick it off, we actually have our first talk is pre-recorded. So we are going to just slide over to that right now.
Hello, my name is Omar Santos, and I'm here to talk to you about different ways on how to get started in incident response without going through a traditional security operations center or a SOC. And let's do this under 5 minutes. Everyone knows about the traditional way to get started in incident response, which is very, very popular nowadays if you want to get started in cybersecurity. And that's actually by going to a SOC or a security operations center. And within a SOC, there are different levels or different tiers, right? So you have basically this environment. You have in traditional 3 tiers: tier 1, tier 2, tier 3. Basically, in tier 1, you have a lot of analysts looking at events and responding to incidents throughout your environment. And those junior analysts, may escalate cases to a level 2 or tier 2 incident manager or incident commander, or there's many names for them. So a tier 2 security analyst. Some other ones, they call it investigators. And then you may actually have a 3rd tier. This all depends in your environment, right? It depends whether you have a lot of resources or not, right? A lot of people or not, right? Now, there are different ways that you can get started in cybersecurity, and especially in incident response, without going to the traditional environment of a SOC. And to explain that, let's go over the different incident response teams and their services and basically their structures, right? So everybody knows about the Computer Security Incident Response Team, the CSIRT, right? That's what I was actually just talking about, what they actually operate in a SOC environment. And of course, those teams also do other scenarios or other services like vulnerability management in some cases. It all depends on the environment, right? And other ones actually perform, threat hunting at probably the mid to upper tier. So in other words, tier 2 or tier 3 analysts perform things like threat hunting and other advanced techniques, right? However, that is not the only way to get started. As a matter of fact, I personally belong to a product security incident response team, a PSIRT, which is a team of analysts and engineers that we investigate basically zero-day vulnerabilities against products and protocols that a vendor may actually offer. So in my case, I work for Cisco, and of course, I investigate all the vulnerabilities in Cisco products, Cisco services, and I deal with a lot of third-party as well as protocol level vulnerabilities, and I work with a lot of industry peers on basically investigating those issues, trying to actually even come up in some cases with exploits to demonstrate how the vulnerability can be exploited and so on. So that's a very different environment than the traditional SOC. Each nation, most of the nations, most of the countries in here, they have a national CSIRT. They may have a separate team or separate entities that actually perform computer emergency response, and coordination capabilities as well, right? So it depends on the country, depends on the environment, right? So that's where national CSIRTs or the CERTs come in, and also the coordination centers. Like, for example, in the US, we actually have CISA, and of course the Department of Homeland Security, and each of the agencies also have their own computer security emergency response team, right? But we also have other agencies that perform a coordination, right, of vulnerabilities and so on, right? And specifically, there's one in the US, which is CERT.org, which is not the same as the US government, but they are funded by the US government, but they are part of the Software Engineer Institute of the Carnegie Mellon University. And they actually help a lot of organizations respond to, vulnerabilities that affect multiple vendors, multiple technologies, and so on. Another way to actually get started, and yes, it's through a SOC, but it's actually through an incident response team for security vendors. And a lot of organizations don't have the resources, both monetarily and also with people, to instantiate their SOC. So of course you can actually work for those type of vendors. But there's one more way, right? And that one is a little bit more tricky because you have to have a little bit of experience or being mentored by somebody that already has some experience in post-breach analysis, right? So those are whenever an incident responder will actually fly, I say fly, right? But it will travel to another location. I'm just going to put location X in here. And they're helping, their customers respond to either a breach, then perform other types of activities, not only to collect evidence, to preserve the evidence and do, things like chain of custody, et cetera, but also demonstrate how potentially an attacker could have actually compromised other environments. They also provide, in some cases, depending on the scenario, proactive services. Now, talking about services, one thing that I would like for you to at least take away from this lightning talk, the Forum of Incident Response Team and Security Teams, otherwise known as FIRST, that's the reason that I said no pun intended. It's a very amazing organization that I actually am an advocate, and I'm actually the co-chair of the open source security part of the PSERF SIG. And they have created different standards and publications, and some of them are related about the services frameworks of either a CSERT or a PSERT. So if I want to actually convince to start your career or further develop your career in a PSERT, one of the best resources that you have is actually this type of, a write-up somewhere. It defines all the different service areas of the PSERT, right? What are the type of models and support that actually provides an organization within the organization and also outside of the organization. They also have, of course, going back to the traditional CSERT, they have a services framework for CSERT, and it's also very, very comprehensive, right? And if you're getting started in incident response team, whether it's you're preparing for an interview, you just want to just see if you're actually going to like it or not, I strongly suggest to at least visit these two documents, and I have a link to both of them in the bottom of the screen. Hopefully this was somewhat useful and under 5 minutes. Thank you and have a good day.
I want to thank Omar for that wonderful talk. Our next talk is by me. I'm Tall Wireless. I'm a network architect. I don't actually work directly in the security space, but I do work very tangentially with security. And my talk is about public IPs are perfectly safe, right? Everyone freaks out when you put a publicly routable IP address on a machine or a host. And I'm here to tell you that there's nothing inherently vulnerable or bad about doing that. In reality, wrong computer. In reality, using NAT in RFC 1918 space adds complexity, right? It adds complexity to your designs. It adds complexity to your troubleshooting, to your maintenance, to everything. And simplicity makes security easier. When you're able to better audit your environment, when you're able to, reason about what's going on, it makes both troubleshooting easier, it makes maintenance easier, it makes transitions easier, but it also makes your security posture much easier to maintain and reason about than when you're trying to manage a ton of NAT rules in RFC 1918 space. But everyone's like, but it's publicly routable, right? But why did you buy all those firewalls, right? The firewalls are there to protect your host, whether they have publicly routable addresses or not, right? Simplify your infrastructure, go for the publicly routable addresses, and make your life so much easier, and then use your firewalls for what you actually bought them for, right? To protect your hosts, right? That could be, a bunch of hardware firewalls in the network. It could be host firewalls on the machines, but they're there. And they're there to protect your systems and your infrastructure. And so use them, but keep things simple. By the way, as a network engineer, route through your firewalls, do not layer 2 through your firewalls, right? And then the real question is IPv6 is something that's coming down the line, right? There is no natting in IPv6. Everything's publicly routable. And if you're not comfortable with handling publicly routable spaces, then when IPv6 becomes the thing, and someday I hope it will become the thing, right? You're just going to have to refigure it all out anyway, right? Because there's not going to be public IP. So you might as well start simplifying the infrastructure now, head for public IP addresses, and re-architect so that you are simplifying your environment and increasing your security posture. Embrace the publicly reliable addresses. Also turn on ICMP. Please, oh please, turn on ICMP. Anyway, thank you. That is my talk. On that note, our next talk is with Hudson. So if I could have Hudson please share your screen and turn on your video, that would be great. Excellent. Hi, Hudson. Let me just...
All right, how do we look?
There you go. You're good to go. The 5
right.
minutes is yours.
Sounds good. So quick talk on Zeke, called Trick or Zeke, using Python with Zeke. Introduction, I'm a security analyst. Actually, before I wrote this, I was relatively new to Zeke and mediocre at best with Python. So,
real quick, Hudson, sorry to interrupt you.
Sure.
The screen share is blinking between the presenter's view and the slideshow itself.
Okay. Let me... All right, how about now?
There we go. Nope, it's
still
doing
same?
it.
Still saying, yeah, that's weird.
So
okay.
let's just keep barreling forward.
All right. Okay. Trick or Zeke. All right. So what is Zeke? Highly structured real-time network data. So a good way to think about it, it's a middle ground between PCAP and NetFlow. So much of the clarity of PCAP without a lot of the overhead. What is Zeke data? It's event-based, generated by the internal events engine. So when something happens on the network, that's when you're going to see an event come through. So an example of a simple event would be just a new connection. These are all stored in numerous logs that track the connection details, along with some protocol-specific details as well. The most basic of these would be the con.log, which would be a record of any of the connections that are passing through your Zeke sensor, as well as some of these other logs, such as X509 that's tracking certificates and SSH. The nice thing about Zeke is that it's open source and customizable. So Zeke includes a scripting language that acts on the events generated by Zeke. Zeke can be used to write customized data to log files based on these events. But what about Python, since the talk was titled using Python with Zeke? Scripting with Zeke isn't always the most intuitive, especially as a newcomer. It was took a little bit of time to pick it up. So it'd be nice if we could do some custom processing with Python. And Zeke actually does have a way to do this. It's called Broker, which is, quote, Zeke's messaging library. What is Broker? That's the way to connect Zeke with Python. It is a type-rich, publish-subscribe communication in Zeke's data model. So you can see here, it's essentially just a way to connect anything you're doing in Zeke with Python. You can publish events from Zeke to Python, so you can do that additional processing. So using this capability, wanted to come up with a way to use it. So the first way I came up with was publish a Zeke package that uses Broker. Zeke passes ASNs observed and external connections to Broker. Then Python picks these up. Python goes through, runs through its logic, and actually performs a request to circle.lose BGP ranking API, which is a database of ASN rankings based on their own discretion. If the ranking is high enough, then Python will actually push this back to Zeke so that Zeke can process some more and write it to a custom log. Originally, when we did this, tried to do it with Zeke. As you can see here, trying to do some different formatting and escaping characters, and it was just cumbersome and was taking a long time to figure out. With Broker, though, was able to do this much faster and have Python do what Python's good at, which was using its libraries to perform these web requests and do the parsing after that. And finally, once the parsing's over, it pushes it back to Zeke and it writes to notice.log. So we have our custom log. Just as a quick demo by screenshot, you can see here some of the top ASNs in circle.lu's database. So taking an IP address, just a random IP address generated from that. Once you have this package installed, you can perform a web request and then going to notice.log, you can see the record being published there. Conclusion, access to Python's library is very useful for doing additional processing on the Zeke event data. Other ways this could be utilized to supplement and add contextual data to your Zeke logs. And obviously the package is open source, so you can use this as a framework to improve and do more. And thanks for listening. Thanks to Zeke for their example on Broker. And you can hit the link here on GitHub to find the package. Thanks.
Awesome. Thank you, Hudson. Thank you very much for presenting. Our next up is Ayush. If you could go ahead and share your screen and your video.
Yes, sure. One second. Can you guys see my screen?
Give me 1 second. Okay, you are good to go.
Thanks. Hey guys, I'll be talking about hunting secrets in code. I am Ayush. I'm an engineer at AppSeco, and I'm a co-organizer for Winja CTF. So to begin with, let's define secrets management itself. So secrets management, according to me, is kind of a process that allows you to like store and use secrets in your application code. And so like the first thing is, how do secrets get leaked in the first place? Talking specifically about how do they get leaked via code. So currently all of us, I mean, like most of us would want to automate our operations and actions so that we can like reduce fatigue and like toil on ourselves. And because of that, we kind of put in credentials such as database credentials or API tokens and whatnot in our code for us, like for the code to perform actions on our behalf, right? The problem arises when we commit those secrets to like a repository via a version control tool like Git. Now the thing is that even if like further commits or future commits you remove those secrets, the thing is that the history always has them. So I can, if I have access to your source code, obviously I can go back to that particular commit and scan for those secrets and still get their values, right? So what can happen if those secrets are leaked? So one of the obvious thing is account takeovers, obviously. So let's say, for example, if I somehow get access to someone's Twitter credentials, or let's say a token or something like that, so I will obviously try to, let's say, post on his behalf. Crypto mining is another thing. So if I have access to certain SSH keys, I can put in certain tools and applications to mine cryptocurrency for me while you foot the bill for it. And then there's obviously the other kinds of monetary damage. Let's say someone leaked their AWS credentials, and then obviously I can launch resources on and then do stuff about that. So this is not a new problem. This is obviously a solved problem, so we don't need to write our own tools for this. There are plenty of tools available. These are some of them that I've tried and tested myself. I personally prefer Git Secrets and Trufflehog because it's extremely simple to install. Like pip install Trufflehog and you're good to go. It also has like around 40 regex signatures for like you to scan for secrets, like something like AWS credentials, Google auth tokens and stuff like that, Slack tokens. The reason I like Git secrets also is like it's extremely customizable and it integrates really well with Git itself. So when you install Git secrets, it becomes like a sub command for Git. So you can do Git secrets and then whatever commands like scan and other stuff. and combine that with like Trufflehog's signature, and then you have a really fast scanner for yourself that you can use. But definitely you can try out the other ones as well. They have their own signatures, their own ways to scan for stuff. There is entropy based scan also that checks for randomness in strings instead of like just regex patterns, which is useful if you don't know what you're looking for essentially. So yeah, you can try that out as well. So the thing about scanning is like you can scan at multiple places, but what would be the proactive action on your end to like uncover these secrets as part of your code? Because obviously nobody would like commit them intentionally. So do you need to scan before you push your code every time? So need to, obviously no, because like in today's modern environment, we know that most of our code goes through, let's say, a central CI/CD setup. Let's say, for example, Jenkins, right? So that could be one checkpoint where we could integrate a scan at build time. So every time a deployment pipeline or a test pipeline is like, it could be a test pipeline that scans for secrets as part of the deployment steps, or it could be a periodic scan. So we let's say have a GitHub organization or something, and those repositories as part of those organization can be repeatedly scanned on a periodic basis. But should you scan like every time you push your code? I would say yes, but we'll get to this point later. So let's say, for example, you already have existing CI/CD setups. It's not that difficult to like integrate a scan. For example, if we talk about Jenkins and we want to use Trufflehog, as I said, it's as simple as doing pip install Trufflehog, and then you could just add a build step in your Jenkins to uncover those secrets. And based on the results, if you uncover a secret, then you can choose not to deploy, or maybe report, or like generate some kind of alert, something like that. But if you want to segregate the tooling from your CI/CD infrastructure, then GitHub Actions is a really cool thing. If you have not used it yet, it's essentially a compute service that GitHub allows you to use for free for a certain amount of usage. And you can offload those scans via remote trigger from, let's say, Jenkins. That scan can happen, the results can be fetched back to Jenkins, and then you can do whatever you were supposed to do anyways. So yeah, you can use that as well. So we looked at scans, we looked at what kind of scans we can do, and what are the places we can scan at. But there are some other places too. For example, Git Hooks for one. Git Hooks, essentially, if you're not aware, is like a set of commands that you can trigger when you do a certain event on Git. Let's say pre-commit hooks would be something that would trigger an action or an operation when you try to commit changes to your code. So that could be one place where you can put in scans, where every time you try to commit your like changes to your code, it will scan for secrets and will let you know, and essentially stop you from committing those secrets in the like from the get-go itself. Push rejection is the other spectrum, essentially, where when let's say a self-hosted GitLab server or GitHub Enterprise, something like that, receives a push from like a developer, it can scan for secrets at that point and then reject based on if it finds secrets or not. The third thing, or something that would essentially be the most proper way to do it, is like creating a secrets management process itself. So there are tools and services, either whatever suits your particular context, but depending upon these, you essentially store your secrets in a secure, trusted environment. This could be HashiCorp Vault, where you set up your own a tool to store your secrets, or AWS Secrets Manager, where you trust AWS with your secrets, and then you fetch these secrets as and when you need. So in transit, your code will have placeholders, essentially, let's say in the form of environment variables, or let's say .env files. And when you are building those dependencies and like packaging your code for deployment, that is when you can fetch secrets from these like trusted places, and then bake in those secrets in your application code, and then finally deploy. So yeah, that's it from my end, guys. Thank you for listening to me, and if you have any questions, you can reach out.
Thank you, Ayush. If you could go ahead and yep, there we go. Excellent. While we get the next person set up, Daniela, you're up next. If you want to ask any questions, feel free to join us in the GrayHat Discord. And our presenters will be popping in and out throughout the next while if you have any questions. But let's see if we've got Daniela all set up here. Daniela, we have a very large black box over your presentation. Oop, there. Oop, is it me? I don't know. The joys of doing this live. Let's try something real quick. Hold on. Nope, that's not it. Nope. You're also muted. Well, let's just keep it going. We'll figure it out. Danielle, go for it.
Wait a second. Apparently, it's something to do with Discord.
Let's just go ahead and keep it moving. Slides are the candy.
Okay, so my talk is it's about answering a common question, a common assumption that we get a lot when we visit our customers, and especially non-IT companies. The sharing doesn't work at all because my screen doesn't. So you're not seeing the slides at all. The slides doesn't work at all. Can you look at my GitHub and share it? It's probably the best way.
If I could get Muteki to go ahead and share her screen and camera and such, and Daniela, we can slide you in later, and I'll pull it up on my other machine.
Yep, I could do that. All right, can you see my slides?
We have slidage, but not
Cool.
videoage. So we're just going to keep it moving.
All right, so I'm going to talk real quick about O365 authentication types in Splunk log, or in the Splunk logs. So I'm echoing. Someone, can everyone else mute themselves, please? Okay. Right. So basically, I have some screenshots from Splunk that cover essentially how different authentication types show up in O365 Azure audit logs. So to be clear, O365 is basically populated by Azure AD, which gets populated from either fully cloud source or from a hybrid or on-prem setup that flows into Azure AD. So Azure AD is essentially the gatekeeper of all authentication in O365. So there's a couple different kinds of workloads that show up in the Azure AD logs as they populate to Splunk and other logs. One of the workloads is Azure Active Directory. So essentially, the first step of an authentication to a mailbox is to authenticate against Azure AD. And this slide shows what those examples look like. So as you can see, it describes the workload name, the operation, user logged in, which is not universal for all log types. And it also shows information such as the user agent, which varies depending on what type of authentication or protocol you're using, request types, and status, which can often be misleading. So there's a second workload for Exchange, and that is when someone logs into an actual mailbox. So the workload now switches to Exchange. And in this example, you'll see the user agent doesn't exist, but there's a client info string. So if you're looking to see what client someone is using to authenticate and to access a mailbox, they may actually be under two completely different headers. So client MS Exchange RPC is actually Outlook, And you can actually see that in the process name. So I did a top for types of user agents. Client info string, that would be a whole different query, so I didn't do that. But you'll see there's a whole bunch of different types. Most of the ones listed are Mozilla, Apple WebKit, those types. Those are usually browsers or modern auth authentications. Peppered in there are actually some iPhone user agent strings, Exchange Web Services, which may be going partially obsolete. But there's a whole host of other ones. And they can be changed if you use something like a fun Python library to access a mailbox programmatically. So you can actually change most of that information. So just because you see it and it looks normal in the user agent string does not mean that it actually is correct or that it is a legitimate source. And another note, ActiveSync is a pretty fun loophole because you can use it with both basic authentication and with modern authentication. It does show up differently in the logs. If you're actually looking for basic auth usage, which can be used to actually bypass two-step verification, you would want to look for client info string client equals MS Exchange ActiveSync. And hopefully that will be changed in the future and actually deprecated or forced to be compatible only with modern auth, but that has not happened yet. And then the second part of that string is the actual device using that protocol. This can actually be used with the native iOS application. And there's actually a bit of a loophole, which is kind of interesting, where you can basically get around a two-step verification prompt that defaults to modern auth, cancel out the prompt, and actually have iOS native app default to basic authentication. So that does exist as a vulnerability. And you'll also notice that the operation here actually says mailbox login as opposed to user logged in from the Azure Active Directory logs. So always keep in mind that your operations and workloads may change depending on what kind of log you're actually looking at. This is an example of mailbox delegation. So you'll see that, again, there's that client info string, client MS Exchange RPC. That's Outlook. The operation is actually folder bind. And what that is my main account or user ID, which is towards the bottom, is actually looking at another account. And the actual account that it's looking at is the mailbox owner UPN. And then a couple last notes. So legacy modern authentication. It's great to say that no one should be using legacy authentication, but realistically, there are plenty of places that still are. So legacy authentication to a mailbox actually shows up as repeated authentications. So you'll see a lot of these logs. Modern authentication goes through an initial authorization or authentication process, but refresh tokens are used instead of repeat authentications. These may or may not be in the logs. I believe that they are coming to Azure AD logs. But if you're actually looking at this in the portal, it's actually a multi-step process. It'll show up as a request to authenticate, interrupt while it defers to a security challenge, and then a success. So it looks a lot different than legacy authentication does. And that's my talk. Thank you very much.
Thank you very much, Muteki, for that. I believe we have figured out Daniela's technical issues. So we're going to have Daniela go. Daniela, you should see the tall wireless user sharing their screen. Did we lose Daniela?
Can you still hear me?
I can hear you.
Okay, great. So my talk is about vulnerability management versus patching. Can we go further? A common assumption that we see at many customers, especially non-IT companies, is they have a great patching program and they're wondering why they should ever run a vulnerability managed program. So it's an assumption that basically we've seen in the last 3-4 years whenever we insist that a whole vulnerability management program is being started at a company. Can we go next? One of these things is just not like each other. patching is normally affects a well-defined category of assets. With customers, we have great understanding of SCCM. They're managing all the application. We even have customers who do whitelisting. So patching is well done, is a good process, but still is not the same as vulnerability management. Because with the vulnerability management program, you answer a few extra questions. Did we address all the assets? Did we test really everything? Because maybe you have a great SCCM, but your TV, your smart TV and your other smart appliances will not going to be managed by SCCM or by other managing tools. Did you really have all the assets? Maybe you just brought in last few weeks a new project and it's not yet in asset management, it's not yet in SCCM. Did we actually test the unfortunate wrong usage of an asset? You can patch an asset, but still deploy it or use it wrong. The link with the YouTube video is for the people to watch after, because, or we can watch it after the talk. Anyway, there's a difference between the two. Let's go to the next slide. Let's have this utopia assumption that you actually know all your assets, that you actually have a program to patch them all 40,567 of them. And then it's just a matter of rat race, especially when you have few vulnerabilities, few high vulnerabilities or critical vulnerabilities in 1 week. In which order are you going to patch? How are you going to decide which one you patch first if your patch manager can just run all of the same category at once? How are you going to test? Where are you going to put your efforts? Let's go to the last slide. The vulnerability management is actually a program where you involve more processes. You look at the policy, you look at awareness, you especially look at prioritization, because you're never going to have time to do everything at once. Then it's the actual patch management. Then you're going to test. Then you're going to tweak, and the tweaking is very important for the difference of the wrong usage of your assets, or let's say a situation in which using two assets together, which were really well patched, can create a vulnerability. And applying, of course, mitigation. So patching is essential, but it cannot replace an entire vulnerability management program. And that was all. Thank you for sharing. Thank you very much.
Thank you very much, Daniela. Next up, we have Randy. If I can get Randy to go ahead and share his screen and unmute his mic. If you can unmute your mic.
There we go. How about that?
Much better. Let me just turn you
Excellent.
down a little bit. Okay, the floor is yours.
All right, thank you very much. I'm going to be talking about unmasking or detecting a stealthy technique that we've seen used by malware. My name is Randy Pargman. I'm a threat hunter at Binary Defense, and looking for attackers that try to evade detection is something that our team does all the time. So let's start off with non-masked, clearly malicious behavior. What if you were looking in your logs and you saw that a Word document running in winword.exe had spawned reg server 32? I mean, if you are a SOC analyst or a threat hunter or an incident responder, this should immediately pop out at you as malicious. This is something that you need to investigate. Threat actors know this too. This is, in fact, a sample from Iced ID delivery document just earlier this month. So what do threat actors do if they know that they're failing? If they know that they're sending these dropper documents and they're not getting a call back to their C2, they know something's wrong, they probably go in and test, they read some of these blogs that we put out there, and they realize this pattern of WinWord spawning reg server 32 or PowerShell or C script or W script, any of those things is going to be detected. So they innovate. This is another document also used by Iced ID to deliver malware, also from this month. But you'll notice something is a little bit different here. Instead of WinWord spawning reg server 32, that clearly malicious pattern, now we've got something weird. Winward is spawning a program called in.com. Let me ask, when's the last time you saw a program ending in .com anyway? And what's more, this is actually running, this screenshot doesn't show it, but in.com is running from the user's public folder. So this is really weird too. And then its command line argument is running in.html. So the question as an analyst is, of course, what is this? If you detected it at all, because maybe you don't have any detections for Winward spawning in.com because you've never heard of that before. Well, if you look at the hash of this file, then you will find out that in.com is just a renamed copy of mshta.exe, legit Microsoft process, but definitely one that you would have on your list to watch out for. If Winward is spawning mshta, which is kind of the Swiss Army knife of evil, you would definitely want to know about it. So the attacker has perhaps broken your detection. What are we going to do about it? Well, idea number one. What if we took all of the hashes of mshta.exe and we compared if a file with that hash is running under a different name? That might work. So this is actually something I tried. The problem is it's really hard to keep up with all the Microsoft updates and all the different legitimate file hashes for mshta. I've shown just a screenshot of some of them that I found on VirusTotal. Really hard to keep up. So idea number two. What if we take a look at some other property of the file? Now, if you go in your file system and you right-click mshta.exe and go to Details under Properties, you'll find all of this great information put there by Microsoft. The file type, it's an application, the product name, Internet Explorer, which is just kind of weird. But then what I really want you to focus on is the original file name. It says the original file name was mshta. So what if we key off of that? Because that's something that Sysmon can pick up on. And we tell anytime there's something running that was originally called mshta, but it's not running like that anymore. So here is a query in Kibana for Sysmon logs coming into Logstash and stored in Elasticsearch. Event code is 1. That means the Sysmon event for a started process. And then we're comparing the winlog event data original file name being mshta to the process executable being anything other than mshta.exe. And lo and behold, it comes up with this test that I ran where the process was running under this renamed name, and it was actually calling JavaScript on the command line to download from a URL and then run this script. Definitely malicious. And if you look at the URL it was getting it from, this is from the Living Off the Land binary and script project. If you don't know about that, definitely go check it out. That is a key resource to keep an eye on. So let's try to expand this. Are attackers only going to use mshta.exe to do this kind of sneaky masquerading? No, of course not. They're going to use lots of different built-in tools. Pretty much all of the 129 binaries and scripts and libraries that are on the LOLBAS project are candidates for this. We don't really want to put every single one of those. So we are going to try something else. Is that telling me I'm out of time?
That's not me.
Wow, that is weird. Okay. Can everyone hear that clock donging?
Yep, I can hear it.
Oh, hey, it stopped. Great. All right, so I am going to speed through the rest of this. What if we did something a little bit different where we check if the file name has been changed at all? We're going to come up with all kinds of weird things here, like PowerShell being renamed to Microsoft, but lots of legitimate things like Google as well. This image mismatch equals true comes from a custom Logstash processing script. And all of the credit for this goes to Brandon George, one of the awesome people on my team. I've got this paste bin URL and password on the next few slides in case you want to take it down. If this is something that you can use, you are welcome to have this and all of the other queries on this presentation. So the last thing I wanted to bring up is let's just try the same thing in Azure Sentinel using KQL. I really love KQL. It's very expressive, reminds me a lot of Splunk, but to me a little bit easier to understand. So this is our final query. This is using Sysmon data, so it's looking for event ID 1. It's checking to make sure that the file name, the original file name, is not blank. and it's not in any of this list that we're going to ignore, these known false positives that we really don't want to be alerted on. It's going to then make sure that the file name and the original file name are both converted to lowercase so that we don't have case mismatch coming up with this alert that we don't want to see. And then finally, it's also going to check if the file name does not match the original file name. But the only reason is because the original file name was missing .exe on the end, which is something Microsoft sometimes does. Then let's ignore that too. So this is the final query, and that is my presentation. Thank you very much.
Awesome. Thank you, Randy. And then our final person is Josh. If I could get you to share your screen. And so there's the thing.
Sorry, I'm coming. Let me... Holy crap, are you serious? Sorry, what's it?
There we go.
All right, you're able to see that?
We have a stream. Hold on.
All right.
Okay. You
Cool.
are good to go. I see
Yeah.
a mountainous island. It looks very nice.
Oh, you don't see my actual slides?
I do not.
What? Ooh. Oh, that's a problem. One sec. Okay, entire screen. Good. You able to see my slides?
I still see a very lovely Mac OS X mountainous range. I think it's
Weird.
Mac OS X.
Yeah. Screen share. Okay. Let me. Dude. It's only letting me select my entire screen, which is correct. Go live. You're
Nope.
not able to. What is going on? Sorry, I have to quit the Discord. Permissions, privacy permissions on Mac OS X, unless somebody knows.
No, not the privacy
what's going
permissions. Okay.
on.
Well, do you know what we'll do? Do you know what we'll do? We'll get you to record them, and we'll put them on our YouTube channel for everyone to digest and enjoy.
Can you present if I give you a link?
If you message to me quickly, I can.
Are you able to see it?
Give me 1 second.
Are you able to see it?
Are you able to?
I sent it to you. Yeah,
Yes.
via
If
Discord.
If you watch my stream, you should be able to see it.
All right. Cool. Yeah, just can you go like full screen on that? Yeah. All right. So I'm gonna have you click your keyboard. It's a lot of left and arrows, so go left. All right. So we're gonna just talk about phishing in general. So you just go left again. We're gonna do this old school. Next. All right, and go down. So if anyone is not familiar with what a phish kit is, a phish kit, you can just press down, man, the down arrow. A phish kit is basically a set of web apps that you're able to, automatically deploy. And some of the critical points around this kind of talk that I was supposed to be sharing out my slides is the ability to actually, utilize some of these phishing emails that we receive on a daily basis, whether it's one or thousands of reported phishing messages. Commonly a lot of organizations take that data. I'm just going to do this without slides. So a lot of them take this, common data and automatically, just discard it. When, the typical process is that a user is automatically reported a phishing message, it goes to our mailbox, and then we bring it in and we may extract attachments, or we may do other lookups with, VirusTotal, Hybrid, whatever those kind of threat intel providers are. And at that point, you may delete the message from the user's mailbox, right? That's a typical workflow. What I propose, and what I think that we all as defenders that have to deal with phishing at all need to do, is actually take one step further. Instead of just stopping at, let's do the blocking of the firewall, blocking of an IP on a firewall, or putting a mailbox rule that, delete that messages, or whatever it is. We need to actually go out to that phishing website and bring that data back. And the main reason is because of how they typically deploy, or these either custom or off-the-shelf phish kits or phishing kits. And these are just basically deployable web applications that you're able to, download. What they typically do, they'll either compromise a website, or they'll have their own hosting, and they'll just upload a .zip and then extract that folder. And that's just their web app, ready to go. It has all their templates. They may have to change, some information, like where they're going to redirect once a user clicks submit on a web form, or whatever. They may, forward that message onto multiple different mailboxes, and they'll have to do some configuration there. But for the most part, all they're doing is automatically, just taking in that data and exfilling it out to wherever they're hosting that information, or wherever they're keeping that information. But what they don't understand, and hopefully they don't catch on, which some do, some don't, but they keep those zips that they originally uploaded, those kits, on those sites, and they're exposable. And, we can, as defenders, go out and download those zips, grab that information. It's typically the path of the URL, and then there's some subfolders to some index.html or whatever kind of page. Typically, if you go up that chain and you just hit .zip on the end of it, you'll get the kit. Additionally, a lot of these kits, if they're even more sophisticated, they'll actually have logging in them. Seriously, they keep this logging infrastructure, there. And every time a user visits, they capture IPs, location, and all that information in one big massive, I don't know, is it like fish.log or whatever it is. And they'll keep it on there. So they don't usually block that through HTTP access or any other kind of protocol. They'll actually just leave it wide open. You just got to find it. And so some of the big things that we can do as defenders is, once we get that reported phishing email, we take that and go out to that site, maybe in a sandbox or, an automated way, which I definitely recommend. And I have code that I can share if you're interested, but go out and grab those logs. It gives you a lot of information, not just about, that single site, but did any of your users actually click on that message, and did they fill out the form? If you have a log of it, use that to your advantage. You know exactly where you're getting that information and what you can do to block it. You can go talk to that user. You can go, remove that message. You have a very specific targeted point. The other way is that you'll also look at it from an IOC perspective. They're downloading, if potentially a C2 or other sites, that you're able to actually download those binaries and do some analysis on them, because they leave them around. They don't leave them around long, but they do leave them around. And so we can go out and grab that information and understand how that malware works. All this gives us is the ability to actually, bring in that information and understand who's actually attacking. Is it a sophisticated actor, or is it just, run-of-the-mill, everyday kind of phish kit? Just kind of depends. So if they're spoofing your website, if they're, making it look like your internal services, your, IT department, more than likely they're in your network already, and they're actually, holding on, or they've compromised the account and they're sitting on that, and they may sit on it for 90 days before they do anything, because they want to learn your behaviors. They want to learn how you actually operate, and they take that information and build custom payloads. They build custom phishing, lures, all of that. But as defenders, we need to stop going with the, just stopping and doing enrichment and blocking IPs. We need to take that information and build upon it. Additionally, there's a lot of different components that you could actually use from a phishing email that we don't typically, suspect. Example, from addresses, tracking all of those. Looking at from addresses across your organization, or how many people actually receive a message from a spoofed email within your organization. Having that data point gives you a lot more of scalability. Well, it gives you a lot more insight into, who's actually attacking and how far have they gone within your network. One of the biggest things to do is track like receive from headers, track paths, look for correlation around open SMTP relays. That typically attackers like to use the same infrastructure. So if there's an open SMTP relay and they're not, they may be spoofing, but typically you can cluster emails in that way. And so you can use like Google Maps and other data to plot those IPs and plot those locations to kind of give you a visual component, or just look at the raw data. But we need to use or utilize a lot of this information across all of the data that we do have that we're not really using to its full potential. Lastly, there's a couple other properties, like, if a message was flagged by the user, that means that they did something. When they reported that message, you can look and exchange logs, query it through EWS, whatever it is, and actually identify if a message is flagged. You can also see if an attacker has wanted a read receipt. All these different kind of components of an email header are advantageous for defenders, and they give you a lot of context. You just have to drill into it. So, sorry about the slides. If you want anything, if you want to talk more about this, or hopefully it was okay for this with no slides and a Marlin. I love this picture, by the way. I have no clue who this person is, but he's so damn excited. So enjoy it, man. Just be responsible, but go find the bad guys, man. Like, just do it. All right. Thank you all.
Thank you very much. Let me just close all the things. Crap. Hold on. Too many windows open. Okay. I want to thank everyone for taking the time to give a quick lightning talk today. And this concludes day one of the Blue Team Village at GrayHat We will see you guys tomorrow morning. I believe the day starts at 10 a.m. Central Standard Time. Keep the conversation going on the Discord server. You can find us in the GrayHat on the GrayHat Discord server under the Blue Team Village. And I leave you with some closing dance music. Anyway, I'll see everyone tomorrow. Bye.
Quick correction. It starts at 9 tomorrow.
Oh, it starts at 9 a.m. tomorrow. I am sorry. Thank you, Muteki, for that correction. But anyway, but still, dance party time. So